Hi there, this is Josiah Winslow recording for his object-oriented programming class at METC. Please ignore the unorthodox location. I would have done this at METC, but it's closed. I decided to do a project from this book, which I got for my own personal use, but I decided to adapt it for this assignment. So, we can go ahead and look at the actual assignment. So here I have a class right here. It's a very simple class that overrides exception, and it returns a custom error message. Now, the program is about being able to decode secret messages where like each character of the message is 3 letters after a punctuation mark. That seems like an odd thing to do, but somebody really did that in the 1600s to break out of jail. And right here, I have a loop that, well, first off, I turn on this thing to have it throw an exception if it fails to read the file. And, you know, I don't have to do that. I don't think I had to do that for this assignment, but hey, if it counts, it counts. So this loop right here reads a file name from input and tries to open it. If it comes across an exception trying to read it, it gives you an error message and tries again. Otherwise, it continues. And it tries to actually read the message to a string stream, which is then converted into a string. And then I also have it print out the file contents. Then I have it input a positive, I have you input a positive integer for the max offset from each punctuation mark to check for secret messages. And then it tries all of them in a loop. It calls my solve null cipher function, which takes in a message, and a look ahead, which is how many characters to look ahead from the punctuation mark. And if I get an invalid message exception, then I output its error message and stop whatever I'm doing from there. And this function itself is a very simple one. It goes through each character of the message, and if it's a punctuation character, it resets the letter count. Right here, I have it keeping track of how many letters after the punctuation mark has been. And I set this flag right here that says we found a punctuation mark. And if there is anywhere between 1 and n-1 letters between punctuation marks, and it fails to find a message, and I throw an exception. Otherwise, if I found a letter, I increment the count and add the characters to the output if the look ahead is equal to the count. I also have this clear screen function, very simple, and an input positive int function. Now, I'm not going to step through it because I basically copy-pasted this from my previous projects, but I also have exception throwing and exception handling for invalid number inputs as well. So, with that out of the way, let's give this a test. So, the file name of the encoded message, I have the original 1600s, excuse me, I think that would be 17th century secret message that was given to the prisoner. And every third character after every punctuation mark spells panel at east end of chapel slides. And that's how he escaped, by exiting through the panel of the chapel. And I'm going to do a max offset 3. And as you can see, this is what you get if you always take the first character after each punctuation mark, the second, and the third, which gives you the proper message. And now, time to showcase some exceptions. So if you give it something which it can't open as a file, it'll give you that message. That's what I said to handle it like. And right here, this test.txt, this is a message that I wrote myself that also has a secret message. Every third character after every punctuation mark. And we are going to look at that message in a second. Enter max offset from punctuation. Now, I have it doing 2 types of errors. One is if you do not input a number, and 1 is if you did not just input a number. Excuse me, that's not it. No, the other one was if it's out of range for an integer. Yeah, there we are. Excuse me, I have both of these cases as the same thing. So sorry about that. And I also, this is not done with an exception, but if it's 0 or if it's negative, I have it returning input must be greater than 0. So I'm just going to say 10 for the heck of it. And as you can see, it's trying to solve the cipher for, look at 1, 2, 3, 4, 5, 6, 7, and it found an error trying to decode it at 7, and then it outputs the error message and stops. And this, by the way, was my secret message for this, and I really hope you take its word. All right. So with that out of the way, I had fun doing this, and it was actually easier than most of my assignments have been lately. So yeah, take care.